Hello everyone, welcome back to another episode in Java. Today I'll be teaching you all about double OP principles in Java. Today I'll teach you about inheritance, polymorphism, encapsulation and abstraction in Java. First of all, let's get started. First of all, I'll teach you about inheritance in Java. In Java, it is possible to inherit attributes and methods from one class to another. We group the inheritance concept into two categories. The first comes the subclass, which is also known as the child, and is the class that inherits from another class. And then comes the superclass or the parent. This class is the class which is being inherited from. To inherit from a class, you must use the extends keyword in Java. So, as I told you, there are two types of classes, subclass and superclass, child and parent. So, to inherit from a class, we must use the extends keyword in Java. Now, let's see an example code for inheritance. First of all, you go to src, select new and select Java class, and let's give this the name vehicle. And inside the vehicle class, we will have a protected string called brand. It's the brand of the car or the vehicle, and we'll call this Honda. And we'll have a method public void honk, and inside it we'll give an S out saying toot. Alright. What we did here was making a class named vehicle and adding a vehicle attribute string named brand, which was equal to Honda. And we made a method inside our class which will S out a toot sound or when we honk our Honda. Now let's see inheritance in progress. Let's make another class, class car extends vehicle. We have just now made another class named car which extends vehicle. This is an instance of inheritance in Java. We use the extends keyword to make our car class a subclass of our vehicle class or the superclass. And now inside it we'll have a protected string model name which will be equal to Mustang. This is a attribute inside our car class. And after that we'll have a main method inside our car class, and inside it we'll make a object out of car. Car C equals new car, and after that we will call our object C and we will print out our honk method from inherited from the vehicle class. And after that we'll S out our C dot brand concat space and C dot model name. Likewise, this is how we inherit from Java. From a class we inherited these attributes. Now we are going to print them and execute the method for our inherited class. So here we have two classes, one named vehicle, the other named car, which will extend to vehicle class and inherit like a subclass from the vehicle or the superclass. And now we have made an attribute named model name inside the car class, and we declared the main method, and we made an object of car class, and we implemented the class method honk, and we asserted the c.brand and c.model name. Now let's see the output for this example. Alright, we got toot toot Honda Mustang. That means our inheritance is successful. We inherited the toot toot sound from the vehicle class, and the car class implemented it and got the sound when honk toot toot, and it got the inherited brand name, which is Honda, and was concatenated to its own attribute Mustang. That's how inheritance in Java is done. Now let's see another example. If we made this string band private, what would happen? We wouldn't be able to access our brand inside our car class. So if we made this private, we wouldn't be able to access our brand from our vehicle class. So that's why we made it protected. Why and when to use inheritance? It is used for code reusability. Reusing attributes and methods of an existing class when you create a new class is what inheritance is. That means the code can be reusable in many ways, and we can reuse attributes, methods from an existing class or a superclass and use them in a sub or child class. Now what will happen if we made this vehicle class final? Let's check it out. If we made it private, we wouldn't be able to extend or inherit our vehicle class from our car class. So we should never use final when we declare classes, because they can't be inherited from another class when we made it private. So in that case we must use public to demonstrate classes. That's why we use public for the class vehicle. Now I have taught you about inheritance in Java. I hope you understood everything about inheritance in Java, like I explained to you. Now let's move on to another topic, another double OP principle in Java. Now let's learn about polymorphism in Java. Polymorphism means many forms. It occurs when we have many classes that are related to each other by inheritance. Polymorphism uses methods inherited from other classes to perform different tasks. This allows us to perform a single action in different ways. That means polymorphism is the ability of an object to have many forms. It occurs when we have many classes related to each other by inheritance. So polymorphism uses those methods to perform different tasks. This allows us to perform a single action in many different ways. Now we'll have an example for polymorphism. We'll have a class named animal, and inside the animal class we'll have a method. We'll declare method public void animal sound, and inside it we'll have an s out saying this is the animal sound. And after that, let's have another class, a class pig, and extends it to animal, and inside it we'll declare our animal sound method again, public void animal sound, and inside it we'll have an s out saying pig says piglet. And now let's make another class, a class dog, and extends it to animal, and we'll have a method in here as well saying public void animal sound, and inside it we'll have an s out saying bow wow bow wow. Okay, this is an example for polymorphism. We have made three classes. We have made a public class animal with a method animal sound which says this is the animal sound, and we have extended it to pig and dog classes, and we have implemented the animal sound method in both of the extended subclasses. In here we have an animal class, and the pig and dog classes have their own version of an animal sound which was there in the animal class. That's how polymorphism works. Now let's implement these methods and classes inside another class. We'll have another class named class main, and inside it we'll have the main method, and inside it we'll make an animal object, animal equals new animal, and we'll have another object, this time a pig my pig equals new my new pig, and after that we'll have a dog object as well, dog my dog equals new dog, and now we'll have our animal class to make the animal sound, and we'll make the my pig have an animal sound as well, and we'll make the my dog to have a animal sound. So in these different kinds of objects we have implemented the animal sound which differs from each one of them. So polymorphism is when objects take many forms and do actions inside our code which was their inheritance. Now let's run this and see our output. What do you think will be the output? Let's print it out and see the output. We got this is the animal sound printed, and pig says piglet printed, and bow wow printed from our dog class. So this is how polymorphism works. An object can have many types of forms, and when inherited from other classes we can use different attributes that look similar to another class's methods. That's how polymorphism works in Java. I hope you got a clear understanding of how polymorphism works in Java. Now let's move on to the next topic. Now let's learn about encapsulation in Java. The meaning of encapsulation is to make sure that sensitive data is hidden from other users. To achieve this, you must declare variable or attributes as private and provide public and get and set methods to access and update the value of a private variable. So that's what encapsulation is. It is making sure sensitive data is hidden, and to achieve this we make our class or variable attributes private and provide public getters and setters to access and update the value of private variables. Now we will have an example for encapsulation in Java. We'll make a class called person, and inside the person class we'll have a private attribute, private string name, and a private age, private int age as well. Now we have made these attributes private. That's the step in encapsulation. And now let's have getters and setters for our class. We go inside our class and we select generate and we select getter and setter. And now we must select all the attributes and say OK. Alright, we have made some getters and setters for our person class. As you can see here, there's a getter name, public string get name, and it returns name. And there's a setter called public void set name, which has a string name parameter, and it becomes this dot name equals to name. And later on we have public in get age, another getter which returns the age. And after that we have another setter which is public void set age, which has a int age as the parameter, and we make this dot age equals to age. So we have made our variables private and provided getters and setters for our class. That's the step in encapsulation. A getter returns the variable name of a attribute, and a setter assigns the parameter value to a new value and assign it to a new value inside our setter. Now we'll have another class. We'll have a class main, and inside it we'll have our main method, and inside it we'll declare a person object. We'll have person, person equals to new person. And now let's try to access our age or our name. We say person dot name. Oh, as you can see here, we can't access our name like that, or even our age. Why is this? It's because we made our attributes, our string name and int age attributes private. We have encapsulated, so we can't call our name and age by an object just like that. Now let's see another error. If we s out our person dot name and run this, what would happen? Let's see. We got name has private access in person. That means we can't use the name just like that by the object. So for this there's a different way. We can say person dot set age first and set our age. We'll give the age 17, and after that we can even set our name. We'll give a name like Alex, and to access these age and name values we can have an s out and print person dot get age and s out person dot get name, just like that. Now let's run this and check the output for our example. We got 17 and Alex printed just like that. That means our getters and setters and our encapsulation process successfully worked. So that's why we got our output like this. So why use encapsulation? It provides better control of class attributes and methods. And also class attributes can be made read-only if you only use the get method, or write-only if you use the set method. It's flexible as the programmer can change one part of the code without affecting other parts. It increases security of data. So encapsulation control attributes and methods and make them read only and write only, and makes it flexible for the programmer to change one part without affecting other parts, and it increases security of our data inside our encapsulation data. Well, now I hope that you got a clear understanding of how encapsulation works in Java. Let's move on to the next part. Now let's learn about abstraction. Data abstraction is the process of hiding certain details and showing only essential information to the user. It can be achieved with either abstract classes or interfaces. The abstract keyword is a non-access modifier used for classes and methods. Abstract class is a restricted class that can't be used to create objects. To access it, it must be inherited from another class. Abstract method can only be used in an abstract class, and it does not have a body. The body is provided by the subclass, which is inherited from the superclass. So abstraction is a process of hiding details. It can be achieved with abstract classes or interfaces, and the abstract keyword is a non-access modifier for both classes and methods. Abstract class is a restricted class which can't create objects, and an abstract method it can only be used in an abstract class, and it does not have a body. Okay, now let's dive down to coding. Now here is an example for an abstract class. We have made an abstract class animal, and inside it we have declared two methods. We can even declare abstract and normal methods inside an abstract class. In this we have a public abstract animal sound which returns void, and another public void method sleep which solves Z sound. That's what we have done in this code example. Now we'll have a class, main class, and inside it we'll have our main method, and let's try to access this abstract class animal. You say animal equals new animal, but we can't make an object out of our animal class, our abstract class, because it's abstract. Abstract classes can't be made by objects. Now let's have another class. This time I'll have a class pig, and it extends it to our abstract class animal, and we get an error line. To remove this error line, we click the red bar and we click on implement methods, and we'll choose the animal sound method and implement it. So we have got our pig class with an overridden method called animal sound. We can give an sout for our animal sound. We say sout and have a sound as piggy, piggy, piggy. Right, likewise. And now let's have another class. We'll have a dog class. Class dog. Class dog extends our animal abstract class. In here also we got our error. That means we must implement our methods from our abstract class. We choose our animal sound and we implement it. And now we have an overridden method and animal sound. Let's give a sound with a value for our dog animal sound. We say bow, wow, wow, bow. Now I'll make an object out of the pig class. You say pig equals new pig. We can make it like that, and we'll have another dog object. You say dog equals new dog, and let's try to access our methods from these two objects. We say pig dot, and we get our animal sound method and sleep method. We'll first implement the animal sound, and after that we say pig dot sleep method, and likewise for the dog we'll have our animal sound and our sleep method. Now let's run this and check our output for our pig and dog objects and methods. Okay, we got our pig sound piggy 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 piggy, and it sound when sleeping zzz, and the dog's sound bow wow bow wow, and its sleeping sound zzz from this example after coding. Why and when to use abstract classes and methods? It achieves security. It hides certain details and only shows the important details of an object. That means we can use abstract classes and methods for security to hide certain details and only show the important details of an object. Likewise, I have now discussed about abstract classes and abstract methods. And in this full lesson, I have taught you about 4 OOP principles: inheritance, polymorphism, encapsulation, and abstraction. I hope you got a clear knowledge about these OOP principles: inheritance, polymorphism, encapsulation, and abstraction. Now it's time to end this lesson. Today's lesson is over, so I'll meet you on another day, another time. Until then, goodbye guys, and please take care.